Welcome to lecture for research methods. We'll be talking this time about matched pairs designs, within subjects designs, and mixed designs. So far, everything we've talked about has been between subject designs, right? Where a participant in the experiment, in the experimental study, receives only one level of the independent variable, right? And at every level of the independent variable, we calculate some sort of group average, and we compare, the mean at this level of IV to the mean at this level of IV. Now we're doing some different things. Whether people get more than one level of the IV, or instead of comparing one mean to the other, we're comparing one individual to another individual. Okay, that's the first time. First thing we're talking about with a matched pairs design. We're no longer looking at comparing one mean to the next. So the process here. Let me give you an idea of what I'm talking about. You start off. You got your participants, and you measure them on some variable related to your dependent variable. So if you're going to be looking at how something affects attention, right, and you're going to use some attention test, you're going to measure their attention using some other attention test, not the way you're going to measure it in the study, but some other way. Say, okay, I want to find out, how well do people pay attention, right, before you do anything to them, and eventually you're going to do something to people. Right? It's an experiment. So to maybe half of them, you're going to give a lot of caffeine, and half you'll give a caffeine-free drink, right? So, but before you do that, give everybody a test and see how well they pay attention. And then you rank them from most inattentive to most attentive. And then you pair similar participants. So the top two, they're a pair. The next top two, they're a pair. The bottom two, they're a pair. So on and so forth. Everybody's got a partner, right? And then you randomly assign one member of each pair to the treatment condition, or the experimental condition, and the other one to the control or placebo condition. Right? And when you do this, it only makes sense if you can kind of think down the road towards the statistics. Because what you're going to do for a matched pairs design, when you're looking at treatment group versus control group, in a between subject design, right, you calculate the average one, the average the other, and you look at the difference, right? Or it's at least for a t-test, right? For a matched pairs design, now we've gone to the trouble of matching these people. So now we have we've made sure that people in the two groups, the two groups are pretty similar, right? And just using random assignment alone makes them pretty similar, but now we can be pretty confident that the average level of attentiveness in one group is going to be similar to the average level of attentiveness in the other, because of our pairs that we've split up and assigned one part of the pair to one group, one part of the pair to the other group. The other thing that we do statistically is when we're calculating the differences, we calculate these difference scores. So the two smartest people, or not smartest, but the people who paid the most attention, one got caffeine, one didn't. And I'm going to compare their scores on the attention measure after one got caffeine and one didn't, and find a difference. Right? And I'll do that for every single pair, right? And if there's no effect, then all those differences should be close to zero. And the sum of the differences, the average difference, should be zero. And if the average difference isn't zero, well, then there's an effect. Right? So by doing this, by following this process and using that kind of statistical approach, it gives you more power with fewer participants. It increases power without having to. A study using a matched pairs design has more power than a similar study with the same number of people that didn't do matched pairs. Right. So you need fewer people to get a higher level of power, which is nice. And you think about, well, why is that? Well, because you're making sure these groups are more equivalent. You're reducing error variance. As you reduce error variance, you reduce noise. When you reduce noise, you make it easier to detect signal or effect. And that's what power is, the ability to detect an effect amidst the noise. Right? Another thing it does is it makes it much more acceptable for you to get a diverse sample. Right? We've talked before about an experience, to have good internal validity, to be able to find an effect. Sometimes it's helpful to have a homogeneous sample, which screws your external validity, but it makes it easier to find an effect. Here, it doesn't matter if they're diverse or if they're homogeneous or diverse, because you're not comparing one group to the other. You're comparing these individuals, and however diverse they are, as long as within that diversity you've got pairs of people who are similar on your dependent variable, then you're good to go, right? Um, so an effective design, a good design, but it's got some drawbacks, like everything. There's potentially an effect of testing on the matching variable. So if before I do the study, I'm already testing you on something, right? And it's possible that that's going to tip people off to what the study is about, right? If I do that, then I've got demand characteristics, and they may start answering in ways that they're trying to help me out, right? And that's going to screw up my internal validity. So if I find an effect, I can't be certain that it's because of what I've done to them, and not rather than because they figured out the hypothesis and are trying to be helpful little participants there. So that's a potential problem. And the other thing is there's a cost associated with it. In terms of time, money, effort. It takes more to do this because again. Just think about practically, you'd have to have some testing period. You'd have to have some amount of time where you could figure out the results of your initial testing on the matching variable. You have to randomly assign people to one thing or the other, and then go do your other study. So that it might involve having participants come back more than one day, which some of them might not come back, and if one part of a pair doesn't come back, the whole pair is lost, right? So there, it's good for power, but there is a cost associated with it. Statistically similar type of design would be a repeated measures or within subjects design. So here, we've got the same thing statistically where we're calculating difference scores, and where if there's an effect, the average difference should be bigger than 0. But with this, instead of two people who are paired or matched and then compared, this is one person being compared with herself or himself, right? So that means that a participant receives all levels of the independent variable. So if it's a drug study, we'll give you 0 milligrams and then measure you on the DV, see what happened to you. Wait a little while, give you 10 milligrams, then measure you on the dependent variable, see what happened to you. Then we'll give you 20 milligrams, right? So everybody gets all levels of the independent variable in within subjects design. The most common type of design, so that's one type. The most common type with this subject design is the pre-post. That's why sometimes called repeated measures, right? So if you're doing a therapy, testing a therapy, you assess somebody's symptom severity before therapy, and then after therapy. And again, when you have there's a group of people, and you have two sets of scores. They're pre-therapy scores and post-therapy scores. And you're not looking at a mean difference between the average severity before and the average severity after. You don't care about that. What you care about is each individual. Did they get better or worse? Right? And then, so you're going to calculate a difference for each person and then average those differences. Okay. And again, the benefit of this is you're increasing power, right? And you need fewer subjects than to do the same type of thing with a between subjects design, right? So if you think about a pre-post design with 25 people, you've got 25 people in the pre and 25 people in the post, which we talked before about. You need 25 people per cell, so you just need 25 people altogether. If you did it between subjects, so you compare people who got therapy to those who didn't, and you wanted 25 per cell, now it's got to be 25 different people in each of those two cells, so that's 50 people. You need twice as many people to do the same type of study. So increased power, because again, people are serving as their own controls, which reduces that error variance, reduces the noise. But problems, potential order effects, right? Depending on what your study involves. But potentially practice effects, because you're measuring them on the DV more than once, sometimes multiple times, right? So again, if I'm giving you different doses of caffeine and measuring your attention, you're taking some test to measure attention, and whatever that test is, the more you take it, you might get better at it, right? So as I'm testing you and I'm upping your dosage, you might be getting better, not because you're getting more caffeine, but it's because you're taking the test more, right? So practice effects are whenever performance increases due to repeated testing. And then the opposite of that, obviously, would be fatigue effects, where due to repeated testing, performance declines. And this is where people get bored. Like, I've answered these questions before, or whatever, and they stop paying attention, they stop trying as hard, and they don't answer as honestly or in as valid a manner. So those two are kind of related. And then you have carryover effects, which are similar. But this is where exposure to the independent variable at one level, the effect that it has on the dependent variable carries over into the next administration of the next level of the independent variable. So imagine again with a drug study where we give you 10 milligrams of something, and it causes a biological change, which causes psychological changes, and we're measuring some attention or whatever, and it's affecting you. And then we wait 10 minutes and say, okay, now give them 20 milligrams and see what happens. We may not be seeing the effect of 20 milligrams. We may be seeing the effect of 20 milligrams after getting 10 milligrams, because at 10 milligrams, some of it may still be in your system, and the effect is carrying over into the next stage of the study, to the next introduction of the next level of the IV. Right? And it could be improving or decreasing in performance. Doesn't matter. Right? All it is the effect that at one level is carrying over into another level. And then the last type of ward effect is sensitization, which is somewhat related to fatigue, I guess. It's just the idea that the more we measure the DV, the more likely people are going to figure out what we're looking at, figure out a hypothesis, and they'll become kind of sensitive to the demand characteristics, and that may skew their responses. Okay. So we can deal with order effects, though, right? And two broad approaches. One will be to look to reduce the impact, and the other is to distribute the impact, right? So reducing the impacts, we'll try to decrease the effect of order effects, make them not as strong, so that the data aren't moved as much by these things. For practice effects, one strategy, or there are multiple, one would be have them practice whatever it is a lot before the experiment begins, right? So if it's some attention test, have them take it 10 times before you give them any caffeine, right? With the idea being that eventually they're going to max out to the best they can do in that test, right? And to a further practice won't improve their performance anymore, right? And hopefully they haven't made 100% on the test. They still have room to go. They haven't hit the ceiling yet. So that then when we get the caffeine, give the caffeine to them, we can see them increase more. And then we say, okay, well the increase is because of the caffeine, not because they're getting more practice. They've already maxed out the practice effect. Okay? If you're worried about fatigue effects, make your study more interesting. Keep it shorter. Be mindful of how long people can pay attention. For one activity, no longer than 20 minutes. It's kind of the max that you're going to get, and not overly demanding cognitively or physically. For carryover effects, the key here is just having a longer delay between conditions. Okay, so if we're giving you 10 milligrams of a drug and measuring, we may not give you 20 milligrams till tomorrow or next week, depending on how long we think theoretically that initial dose should have an effect, and when that effect should no longer be affecting you. Excuse me. And then for sensitization, the best thing there is to have a good cover story, a good lie to distract them from your true hypothesis. So we can reduce the impact. Or another approach, kind of general approach, is to look to distribute the impact. So, and you might do these other things too, or I'm going to reduce the impact as much as possible, but if I say, well, I know there may still be some order effects, and I'm worried about the order effects being confounded with the independent variable, right? So, again, I'm giving 0 milligrams, 10, 20, 30, and I'm thinking practice effects, right? Again, I can max out the practice before they do the thing, but it still might have an effect if I give everybody 0 and then everybody 10, everybody 20, everybody 30 milligrams, right? I do it at those levels for every single person. If I do that, if there are practice effects are confounded with the independent variable, right? So people get more practice, everybody gets more practice as we move along levels of the IV. Right? I can break that up and say, okay, well, people may get this practice effect, but if I switch up the order that people get stuff in, and not everybody gets it in the same order, then that effect won't vary systematically with the independent variable. It'll no longer be confounded. Right? And that's how you distribute the impact. So we're going to minimize the impact as much as possible, and whatever's left, we're going to distribute equally so that it doesn't co-vary with the independent variable. Two ways to do it. One would be randomization, right? So you have a couple of different orders, and you just randomly assign participants to these orders. The more sophisticated way of doing it is counterbalancing. Right? And this is where, excuse me, basically each treatment, each level of the IV is received in a given position or order by an equal number of participants. Right. So again, if I've got maybe just three conditions, 3 levels, 0 milligrams, 20 milligrams, or sorry, 0, 10, and 20 milligrams. Right. And I've got 30 participants. Right? And it's going to be within subjects. So all 30 are going to get all 3 levels. 10 of them will get the 0 milligrams first. 10 of them will get the 0 milligrams second. 10 of them will get the 0 milligrams third, and so on and so forth. And you can use something called a Latin square design, which you can find in your book and also online, that can help you figure out exactly what order to give things in, depending on how many levels you have. Obviously, if it's 2, it's easy. Half get A and then B, and the other half get B and then A. Once you get 3, a little more tricky. Once you get to 4, a little more tricky. Beyond 4, it gets fairly complicated. But still, with 4, it's not too bad to be able to come up with a good counterbalancing system, so that people get equal numbers of persons get these different orders, right? And if you do that, and if you do counterbalancing or randomization, you keep track of who got what order, and then you can look at order as a variable to see if it had an effect. So you say, okay, if they got this order or this order or this order, did the performance on the dependent variable differ depending on what order they received the IVs in? And usually you hope that that's not significant, that there's not an effective order. Usually, because you're kind of out to get rid of it. But sometimes you're interested. Sometimes you think, well, gee, I wonder, especially with drug studies, I wonder if people are most successful if we give them increasing doses, or if people do better if we start with a high dose and then titrate down. Right? And looking at the effective order may be an important question for you. Typically not in our field, but potentially it could be. Okay, so match pairs design, repeated measure within subject design, and the mixed subject design is really just a combination of a repeated measure design and a between subjects design. Right, so it's when you have more than one independent variable, at least 2, right? Maybe more, and at least one of the independent variables is a between subjects variable. So at least one independent variable, everybody gets only one level, right? And then at least one other independent variable is within subjects, such that everybody gets every single level. Probably the most common mixed subject design you'll see is like a pre-post therapy design, where you have to compare 2 different types of therapy, cognitive behavioral therapy versus psychodynamic therapy. Right? You have 2 different groups of people. So people don't get both types of therapy. You only get one type. You only get one level of that variable, therapy type variable. So that variable is between subjects. But if we're measuring people in both groups before and after therapy, well, people in the psychodynamic group, you're the same people before that you are after. Same for the CBT group. So that's the time is a within subjects variable. So as you have one of within, one between, it's a mixed subject design. And then the stats are a little different. It's a combination of 2 things. Okay. Last, in terms of choosing design overall, things to consider. How difficult is it to get a lot of participants? Right? And if you have no problem getting plenty of participants, typically you do a between subjects design. Right? Because you don't have to worry about order effects or any of those other things. It's just simpler. Logically, as long if you can get plenty of power and plenty of participants, no worries. Do between subjects. If that's a concern, you might consider within subjects or match pairs, or maybe even at least a mixed subjects. Make one of your variables within subjects. Right. So along those lines, you want to consider the potential impact of order effects. So okay, I really need. I don't have any participants, but if I do within subjects, what's the possibility of order effects, and can I account for them? Can the steps that we've talked about, strategies, work in this situation, right? And if so, go within subjects. If not, you may have to go between subjects and have kind of a fairly underpowered experiment, unfortunately. And then lastly, perhaps obviously, the nature of the phenomenon. in terms of kind of within subjects versus between subjects. Do people experience more than one level of the independent variable, right? In the real world. So, if we want to know what are the effects of watching varying amounts of television, 5 hours a day versus 10 hours a day versus 20 hours a day, people may experience all those different levels. So it may just be, oh, I'm a 5 hour a day person. No, maybe some days I watch 5, some days I watch 10, some days I watch 20. So if people really do get all the different levels, then it may make sense to look at that in a within subjects kind of way. If it's something that people typically only get one level of the independent variable, especially for kind of quasi-independent variables like gender, ethnicity, makes more sense to do between subjects, obviously. Okay. Excuse me. All right. Well, that's all for now. Take care.